The last part in this section is sandwich theorem. It's a very powerful idea. If you look at the screenshot, I know there is a lot to read. You don't want to read it at all. Let me simplify that for you. We call this the squeeze theorem. It's also known as sandwich theorem. So how do you make a sandwich? Let's forget about math. In your kitchen, you are trying to make a sandwich for lunch. How do you make it? First, you need 2 pieces of bread, right? Or 2 pieces of toast. One upper layer, one for the top, one for the bottom, right? Suppose the green one is the toast on top, and then the blue one is the toast on the bottom, and then what do? You want to make the sandwich more delicious, right? So you are trying to put some beef, lettuce, you are trying to put a tomato, right? You want to pick a big piece of beef in the middle, and then you sandwich them in the middle, and then you eat the sandwich. So the stuff that you put in the middle, I call that a pink function. So a pink function. So here is your beef. You have a pink function right in the middle. And then these 3 functions, they are touching each other. Listen to me. They are touching each other only at this point. 1 point only. They are touching each other at this point. And we can clearly tell that the pink is between green and blue. All right, the pink is between green and blue. The beef is between the upper layer and the bottom layer. And imagine that they are touching at 1 point only. So at this point, I can take a stick. Let's use a different color. I can take a stick and then poke through the sandwich right at this point. So what is the squeeze theorem for? When you evaluate limit, when you see the function of sine and cosine, most likely you will have to apply squeeze theorem. Why? If you take a look at the first problem, so that one as x approaches to 0, we have 1 divided by 0 for sine, right? So 1 divided by 0 is undefined. There is no way to check the left and right. There is no way to do any algebra to get rid of the 0. So at this point, when you see sine and cosine, that is a good sign of using squeeze theorem. When you see a sine or cosine in a limit problem, most likely that is a squeeze theorem problem. So let's go ahead and solve the first problem. It's pretty easy. So the first problem, we have limit as x approaches to 0. We have x squared times sine of 1 divided by x. Let's read the note. If a function has a sine or a cosine function, try to use the squeeze theorem because the range of both functions oscillates. What is oscillate? Oscillate is bouncing. So what is the graph of sine? The graph of sine looks like this, right? Starting at the origin and then go up and down, that is 1 period. And then up and down again, that is another period. So sine and cosine, they are both between bouncing -1 and 1. Y equals to 1, y equals to -1. It's going up and down, up and down, up and down. It's bouncing between -1 and 1. When you see that, when in a problem like this, most likely we will use a squeeze theorem. Let's take a look at the cosine as well. So that is 1 period to the right, and then 1 period to the left is bouncing between 1 and -1. So going back to the problem, we are not going to start with the sine at this point. So what we are going to do is, I am going to state a fact that the range of sine of x is between -1 and 1. All right. So now, if I change the x to 1 divided by x, that is also between 1 and -1. If you still remember your trigonometry, change the x to 1 over x does not affect the amplitude. All right, that means sine 1 divided by x is still bouncing between 1 and -1. All right, and then you look at the problem. There is a x squared. So to make this compound inequality look like the problem, I have to multiply each side by x squared. So this this and that, multiply them by x squared. So you have negative x squared less than or equal to x squared times sine of 1 divided by x less than or equal to x squared. So this point is very clear. This is my function f, this is my function g, or this is my function g, and then this is my function h. This is where the sandwich is. So the function g is your beef, the stuff you put inside a sandwich. The f is the upper layer, the toast. The h is the bottom layer. So if you go back to my graph, this is f, this is g, this, it doesn't matter which one you call that f. I will just copy the problem. So this is f, and then this is they call that h. Okay, it's fine, it's fine. So you can call that f because I already put that right here. But okay, let's make it consistent. So I will call that a h. Oh, okay, I was right. This is supposed to be a h. I was right in the problem. So this is supposed to be h. This is supposed to be g. So f and h, they are the toast. One on top, one on the bottom, and then g is the beef. The beef, the lettuce, the tomato you put in the middle. Why do we have to do this? Because the limit of function g is very complicated. If you use no technique, it is impossible to evaluate what it is. However, the limit of f and h are easy. So if you look at the limit of as x approaches to 0, you have a f, which is negative x squared. You can just plug in a 0, right? If you look at the limit of h, that is x squared, that is just equals to 0. So that means this is a 0, this is a 0. What kind of number is sandwiched between a 0 and a 0? The answer is 0. That means function g is just a 0. That's why I said you can use one stick and to poke through the sandwich, and then the stick will connect these three pieces at one point because they are touching each other at this point. In this function, the f, h, and g, they are touching each other at x equals to 0. So if you want to give me an impressive answer, you can say 0 is less than or equal to limit as x approaches to 0. You copy the problem one more time, and then this is sine of 1 divided by x less than or equal to 0. So obviously, this is equals to 0. You can say by Squeeze theorem. Theorem, you can write THM for short, by Squeeze theorem. So that is how we do it. Okay, let's do number 2. So number 2, we have a limit as x approaches to 0 from the right. We have the square root of x and then e sine of pi divided by x. Alright, so I will start off with a sine of pi divided by x that is still between 1 and negative 1 because you have x in the pi divided by x doesn't change the amplitude, that changes the period. Negative 1 and 1. And then you raise each term to e. So e to the negative 1, e to the sine, pi divided by x, and then e to the 1. If you don't understand, if you cannot process this math, how about this? Negative 1 is less than or equal to 0 is less than or equal to 1. E to the negative 1 is less than or equal to e to the 0 is less than or equal to e to the 1. So that is 1 divided by e, right? This is a 1, this is a e. What is e? E is around 2.7. So if you change that to a 2.7, you can clearly see that the inequality is true. If you take e and then put each term in the exponent, and then you multiply the square root of x, so you have square root of x, I should change back to yellow, and then this is e to the negative 1, square root of x, e to the sine of pi divided by x, and then square root of x, e, right, to the 1. So this is my f, this is my g, this is my h. let's check out the limit of f and h. So we have limit as x approaches to 0 from the right, square root of x, this is defined. So square root of x, so square 0 plus is just like the square root of a little bit more than 0. This is defined. Alright, it's close to 0, but at least it is defined. So that is a 0 divided by e, that is equal to 0. And then the other limit is square root of x times e, which is 0 in square root times e, that is equal to 0. So since the limit is sandwiched between two 0, so we have this, the limit is sandwiched between two 0. So what kind of number is between two 0? Which is 0, right? So this is equals to 0 by Squeeze theorem. So that's how you solve a limit using Squeeze theorem. It's a very powerful theorem. So let's do some cosine. Number 3, we have a limit as x approaches to infinity. We have 2 minus cosine divided by x plus 3. So first we have to point out that cosine is bouncing between -1 and 1, and then we will just add the other pieces to it. First, this is why I pick a minus in front of cosine. To get a negative cosine, you have to multiply each side by -1. Again, you have to multiply each side by -1. In inequality, when you divide or multiply each side by negative, you have to reverse the direction of the inequality symbol. Let me say this again. When you solve an inequality, when you multiply or divide, only multiply and divide both sides by negative, you have to reverse the direction of the inequality symbol. Okay, so multiply each side by -1, so this will be a 1 greater than or equal to negative cosine, and then greater than or equal to 1. Imagine this, you have -2 less than 5 less than 10. You multiply each side by -1, so this will be a 2, right? This will be a -5, this will be a 10. Can you -10, can you still do this? Is this true? No, -10 cannot be greater than 2. This is not true, right? So this is true. That is the reason. Okay, and then we add 2. Oh, one thing that I would like you to do, if you are not comfortable with this order right here, you can switch them back. You can do -10 less than -5 less than 2. I will switch my inequality right now. Oh, by the way, forgot a -1. So -1 less than or equal to negative cosine x less than or equal to 1. And then you add the 2 to it. So add 2 on each side. 2 minus 1, 2 minus cosine, and then a 2 plus 1. And then you divide each side by x plus 3. So 2 minus 1 divided by x plus 3. 2 minus cosine x divided by x plus 3. And then a 2 plus 1 divided by x plus 3. Of course, you have to clean it up for me. So this will be 1 divided by x plus 3, right? Actually, let's do that in the limit. Let's take the limit right now. So we have limit as x approaches to infinity. We have 1, right? Divided by x plus 3. So infinity add 3. What is infinity? What is infinity? Infinity is a value that is positive and very, very large. If you look at the number line, you have 0 in the middle, negative on the left, and positive on the right. What number is on the right end? What number is on the left end? Is there a such number? What is the biggest real number that you can think of? Do you have such number in your mind? No. What is the biggest negative can you think of? Can you come up with such number in your mind, on top of your head? Can you come up with such number? Are you able to write this number on your paper? The answer is no. We don't know what that number is, so we use infinity. Same thing right here. We use negative infinity. We don't know what it is, then we use a symbol to represent this. I don't know, all right, then I will use a symbol then. You don't say you don't know on paper, right? You use a symbol. So that is 1 divided by infinity, 1 divided by a very large value is equal to 0. And then on the other side, you have a limit as x approaches to infinity. This is a 3 divided by x plus 3. Same thing, you have 3 divided by infinity. Infinity, that is a 0. So now, since the limit is sandwiched between two 0, x approaches to infinity, 2 minus cosine x divided by x plus 3 less than or equal to 0. So the piece in the middle is equal to 0 by Squeeze theorem. By the way, if you look at the graph of cosine, cosine looks like this, right? That is one period, that is another period. It's bouncing between 1 and -1. As x approaches to infinity, it will just keep going. This piece will just keep going. You will never know what y approaches to because it is keep bouncing between -1 and 1. You won't be able to determine a y value as x approaches to infinity. So overall, the limit is equal to 0 by Squeeze theorem. All right, so let's move on to number 4. Every time I solve a problem like number 4, people ask me a lot of questions in the inequality. So let's do number 4. To make this more serious, I will change color. So number 4, we have limit as x approaches to infinity. You have cosine square 2x divided by 3 minus 2x. When you square a cosine, what happened? When you square a cosine, what happened? When you square a function. When you square a function, there is no more pieces under the x-axis because everything under the x-axis, y is negative. When you square a cosine, you just bring this back to the top. So after you square, the cosine function will just one mountain, another mountain, another mountain, just like many parabolas when you square a cosine. So first, let's start with this. Cosine 2x, again, the 2x doesn't change the amplitude. The 2x changes the period only. So the amplitude is still, it's not really the amplitude. The range is still between 1 and -1. Now, once you square both sides, I mean each side. Once you square each side, now watch. This is -1 square, right? In theory, it is supposed to be 1. And then this is cosine square 2x. And then this is supposed to be 1. Alright? However, look at the graph. If the range is between 1 and 1, then then you don't see this, right? What is this between? This is between 0 and 1. That's why when you square, this is actually a 0. This is actually a 0. It's between 0 and 1. This 0 and this one is not between 1 and 1. If this is between 1 and 1, you have one line. You don't have so many parabolas. So people ask me this all the time. Let's keep going. You divide each side by this. Alright, now the setup is done. And then next, you take the limit. So this is already a 0, right? So this thing is already a 0. So the limit the limit of x approaches to infinity is 0 divided by 3 minus 2x, because this thing is already 0. So that means the function is always 0. So this is just equal to 0. And then on the other side, you have 1 divided by 3 minus 2x. So plug in an infinity, you have 3 minus infinity. 3 minus an extremely huge value, that is negative infinity, right? So this is equal to 0. So since they are both equals to 0, then we say that this is equals to 0 by Squeeze theorem. So that is how we do this problem. All right. So that will be end of this section. I will see you all in the next lesson. See you there.